Hello, everybody. This is Dr. Surush Azizi, and today we want to talk about portfolio optimization using Excel Solver. What does it mean, portfolio optimization? A portfolio is a basket of investment. When you have multiple assets in the basket of investments of yours, we call that portfolio. When we say portfolio optimization, essentially that means you want to maximize the return of the portfolio for any given amount of risk that your portfolio has. So you want to maximize the return of the portfolio based on for any given level of risk. That's the meaning of portfolio optimization. Now, let's assume you have n different assets, for example, n different stocks in your portfolio, and you want to maximize the portfolio return for any given level of risk. How can we do that? One thing that we have in hand, one tool that we can play with is the weight of each stock in the portfolio. They can be any number between, for example, zero. If we exclude short selling, they must have zero or positive weights and up to one. So you can change the weight of different assets in your portfolio to maximize the return, and that's exactly what we want to do. So for this purpose, we need something. We are going to do this in Excel Solver. So in order to that, we need to open up an Excel workbook, and I'm gonna share my screen with you to see how exactly we can do this. So let me share my screen with you. So this is an Excel file, and we want to start doing this portfolio optimization in Excel Solver. So this is the Excel file that we have. And for this, let's make sure that we have the Excel solver. How can we do this? So all you gotta do is to go to tab data and make sure that you have this, oops, Excel solver. So I'm gonna move this. I'm gonna go to tab data and see, here is tab data, yes. So I'm gonna move this down here. On tab data, on Mac, you might not have this Excel solver. So on Mac, if you go to Analysis Tool Pack, you see all the options here, and you can just easily click on solver add-in and click on OK, and then you're going to have the solver. This is the face of the solver. On PC, on Windows PC, you can go to File, Option, Add-ins, and then Add Solver, and then click on Go. Sometimes you have to close the Excel file and open it up again, but essentially that's what you want to do. So let's get started with this portfolio optimization. So for that, we are gonna select a portfolio of different stocks, and we are gonna limit ourselves to a time limit. So I'm gonna start with saying, for example, uh, start date, start date and end dates that I want to focus. So start date can be, so we are gonna focus on a 10-year period, starting from January 1st. So January 1st, 2015, and the end date can be something like December 31st, 2024. That's 10 years of data. So we are using 10 years of data for this portfolio optimization that we have in mind. Now, the very first thing that you want to do is to select your portfolio and download the historical return. So I'm gonna go here and I'm gonna write the word ticker now or tickers. So, and I want to focus on five different stocks. Ticker essentially is a symbol for any company. Any company that you have, you can just go and Google their tickers. And if you just, for example, say ticker for a company like Apple, it very first page on Google gives you the ticker. So, for example, for Apple is AAPL. Yes. So AAPL is the first company that we want to focus. Let's select four other companies. There is a reason I wrote it twice. Just it doesn't matter. Just write it as this. Just we're gonna use it once. Yes. And then I'm gonna focus also on, let's say, Tesla. The ticker for Tesla is TSLA. And another one that I want to do is Google. So the ticker for Google is GOOG. And then Walmart is WMT. And the last company I want to focus on is Coca-Cola. That's, sorry, KO, not COKO. So these are the companies that we want to focus. So the very first thing that I want to do is to just download the historical data that we have. How can we do this? How can we download historical data? There are many different ways. Either you can download them from Yahoo Finance and copy and paste them here, or different things. But one way that in Excel easily you can do that is with a function that we have here, uh, equals stock history right here. So equals stock history, and then I can just easily select, for example, the name. So the first one, you see, like right here, when as I'm filling this, it gets bold. It means Excel is expecting me to enter this information. So the very first information that Excel expects me to enter is stock or ticker, which is like AAPL. Then as soon as I put the comma, start underscore date gets bold. So I want the start date to be here B1 this day, January 1st, 2015. And then end date. End date can be like December 31st, 2024. And then interval. So for interval, we can either put 0 or 1 or 2, daily, weekly, monthly. So it's a common practice in portfolio optimization that use a uh, monthly data. So I'm going to select two, and then do I need headers? Not exactly. I do have the headers, so I don't want that. I put 0, no headers. And then do I want, next one is properties. So it can give you different properties, yes. So let's take a look at the properties. Do I want the dates? So if I want the date, I'm gonna put 0. So only for Apple, I'm gonna say yes for to the dates. What other properties am I interested? Close, open, high, low volume. I'm not gonna use open or high or low or the volume. I'm gonna just focus on close. So I'm gonna put 1 for this one, and that's it. You have this, just hit enter. It's going to take a few seconds, and it's going to give you all the data that you had that you wanted. Yes. So the data is starts from ends right here. So let's see how many rows we have. We have all from row 5 to row 124. That means, including 5 and 124, that means 120 rows. That means 10 years of monthly data. Perfect. I got the data for Apple. Let's move on to the next company, which is Tesla. So I'm going to do almost exactly the same thing. I'm going to start with equal sign, stock history, and I'll double click on this. Stock is going to be Tesla, and comma, start date is going to be this, end date is going to be this, and then interval would be monthly again. Categories, no headers. Do I need the date one more time? No, the date would be exactly the same thing that as we had for Apple. So here I'm going to just focus on close. I'm going to just say comma 2, comma 0, comma 1. And I'll hit enter. It takes a 1 second and then it downloaded the data for me. So exactly same dates, and this is the data for Tesla. Then I'm gonna do on for Google. For Google, I'm gonna again click on stock history, type stock history. Then stock is Google. Start date would be here, end date would be here. And then do I want monthly? Yes. Do I want header? No. Do I want close? Yes. I'm gonna hit enter. I got all the data that I wanted. Now that I got everything, I'm gonna just focus on Walmart equals stock history. And then here, this is the uh, company start date, end date, monthly, no header, and then close. Hit enter. And the last one, Coca-Cola. You can do for more than five companies. You can do for 10. You can do for only, I don't know, two or three. I'm right doing for five. If you want to do it for any other number of companies, the procedure is exactly the same, but you have to select a number for number of companies. I selected five companies. Start date, end date, interval, again, monthly. Do I want headers? No. And then I need the close date, and boom. Everything is downloaded. Perfect. That's really good. So far, what did we do? We downloaded the data for five different companies and for 10 years, from January 2015 all the way to December 2024. 120 rows of data for five different companies. Now I'm going to call this worksheet or tab data, and I'm going to create another tab. I'll call this calculation, and I'm going to here copy all the data points that I have, copy them, go to the tab calculation, and then on cell A2, not A1, but A2, I'm gonna paste them as values. How can we paste them as values? Right click on Mac, that means hold down the control button and then click on paste special values. And here, why do I left the first row empty? So maybe this is such an important topic. There is a very good chance that in a year from now, 5 years from now, you want to get back to here and see what's going on. So I want to be as clear as possible. And for that reason, I want to give the, appropriate names to each table. And we are going to make many, many different tables. So I'm going to call this table, for example, uh, stock prices. Stock prices. Yes. So the first row would be appropriate name for each table. And then this one, so I pasted all of them as values. You see, these are values. They are irrelevant or independent of this tab. So here I'm going to change this AAPL to the appropriate name for this, which is dates. And then one more thing that I want to do is this. I'm not very happy with this sign that, with this dollar sign that we have. So I'm going to select all the data that we have, and I'm going to click here and make it maybe number. Yes, much better. They're all numbers. So far we downloaded all the data for the portfolio of the investment that we wanted. Great. Now I'm going to calculate another thing. I'm going to calculate, uh, let me just copy and paste these names on, let's say here. I'm going to calculate the growth for each of them. So I'm going to name them AAPL underscore R, R for rate. You can use G for growth. I'm going to just be using R for rates, Walmart underscore R, and then KO underscore R. And then the first column would be exactly the same thing. So I'm going to copy this and paste it over there. But so this uh, table is called, let's say, stock price growth. Yes, uh, or rate of change, rate of price change. So that's the name of the table. And so how can I calculate this? Like I want to see what's the percentage of change when Apple price uh, went up from 29.29 to 32.112. What's the percentage change that change? So from mathematics, we know that if you have a variable x, if variable if value of if value of variable x increases or changes from x1 to x2, then the rate of change is calculated as this. Percentage wise is calculated as this, equals how much it, like 100 times, because we want to report it as percentage, yes, times the change, which is x2 minus x1, divided by the initial number x1. So this is the formula that we have. Yes. I'm going to use explanations. I'm going to use that to calculate this formula. I cannot calculate for the first row. Why not? Because if I wanted to say 29, like if this was x2, I needed one data for the line before that, and we don't have that data. So I'm going to leave the first row of the table blank, and I'm going to start from here. I'm going to say equals 100 times, open the parentheses, this guy, the second number, minus the first number, and then divided by first number. Look at the colors and how the colors match different cells that we have. And I'm going to hit enter. When I hit enter, go back to that cell. Either I can just double click on this like very small green square, or I can just scroll down. Both of them work. Yes. So if that's the formula for this, I can either type the formula for Tesla. There's another way that I can just drag that formula to right and it calculates it for me. So if I just click on this one, I can see that the formula is adjusted based on the cells. And I can go back here, double click on this point. It calculates all the numbers for me. So that's a good thing. So what did I do? I just calculate the monthly growth or the monthly change for each of these five companies from so for 119 rows. And these are in percentages. Great. Now, in Excel, something that we can do is to name each series of numbers. For a reasons that we are going to see later on, I'm going to select all of these rate of change and right here, let me close this disclaimer. Right here, I'm going to call this AAPL underscore R. We're going to see the reason that I'm naming this. There's a reason behind it, but I'm going to keep doing that for every single column. So that was TSLA underscore R. Great. So let me make sure that, and if I select this one more time, I can see that yes, the name is over there. After that, I'm gonna do for Google GOOG. So I'm gonna select all of these data and I'm gonna call that GOOG underscore R, enter, WMT. I'm gonna select all of this. So this is something necessary. We have to do this. WMT underscore R, and then the last one, KO. I'm going to select this row. So it's necessary. We are going to see the reason for this later on, KO underscore R, and hit enter. Perfect. So far I calculated this and I calculated the uh, rate of price change for every single company. So far, everything is great. I have a portfolio of five different stocks with different prices, and I calculated the rate of price change for them. Next thing that I want to do and I can do is to calculate averages and variances. So I'm gonna create this table that I'm gonna be calling that AVG and VARs. Yes. So for each of these five different stocks, I'm going to calculate. So I'm going to copy all of these names and then paste them right here. And I want to calculate four different things: monthly, average, and monthly variance, and annual average and annual variance. Great. So I can easily do this calculation. The formula for average is just simply average, yes? So let me, maybe I could just write this over here, and then this one over here. And then, so next point I want to make is this. To calculate average, use, what do we want to use? Just equals average. That quote mark that I put, it just makes it like a string, like letters. So you can just ignore that quotation mark that I put over there. But so I'm going to just use equals average, and then I can just select the data for Apple. If I select all the data, something funny happens. Is that here, it just puts the name that we had over there. So I can just hit enter, and the average monthly growth is for Apple is 2.13%. I'm going to use the same thing for Tesla. Let's see if I can, if I do this, does it work? Nope, it doesn't work. So I'm gonna just type equals average and then select. I can just also just type TSLA underscore R. And as soon as I type this, this column would be highlighted or selected. Yes, I can just select, do that as well. Or equivalently, I can just type average and then select this. They are both the same thing. As a matter of fact, that's a good way to make sure you have done right, a correct thing. So equals average, and I just select everything for Walmart. And one more for Coca-Cola. I'm gonna do equals average and select all of these rows. And let's see. Yes. So I calculated the average. In between all of these four different stocks, in the 10-year period from January 1st, 2015, all the way to December 31st, 2024, uh, Tesla has the highest monthly growth rate of 4.34%, then Apple, then Google, then Walmart, and then Coca-Cola. So that was the monthly average. If I want the annual average, there are different ways to calculate monthly to average. I'm going to just say 12 times monthly. That's maybe the easiest. And then I'm going to just drag it to right. Great. How about monthly variance? So if I want to do monthly variance, I can just click on equals and then type var. As soon as you do, there are multiple things that they come up. var.p and var.s. Which one should we choose? We are going to focus on var.s, yes, to calculate variance, use uh, equals var.s. Why dot .s? Why not dot .p? Dot .s stands for sample. Dot .p stands for population. We don't have access to the data for population. Population means if you have access for all the stocks for all the time. And so we are going to focus on just sample that we have. It's a sample. The data that we have is just a sample. Yes. So here I'm gonna use that formula to calculate the variance. So equals var.s. And then again, either I can just do this, or I can, so I can either just type this or do this. So again, if I just do this, if I drag it to right, it's not gonna work. It's gonna give me the same numbers, yes. However, what if I'm gonna do Command Z rather than this? If I click on this guy, would it work? No, it's gonna say division by zero. Why? Because this is not the series that we have. Is there any way that we can make it a little bit easier? So there is this function, indirect function that we have. And if we do that, then it works. Let's see what happened. So here I'm saying dot equals var dot s, then inside parentheses. So I wanted to type AAPL underscore R. But if I just click on this cell, Excel would think that, oh, I mean, I'm talking about letters AAPL underscore R, it doesn't know I'm referring to the actual series that AAPL underscore R represent that. So it would give me an error without this indirect function that we have. If we just did this, it would give me an error because it doesn't know this AAPL underscore R is what we meant, is the series that we want. For that reason, I'm going to use this indirect function. When I use this indirect, so I'm going to, let's say, equals var dot s, and then I'm going to use indirect, and then I click on this one. Then Excel knows that, hey, by this indirect P2 is, I mean this series that I had over there. And I click on that. And when I just just scroll down to the right, let's say like this one, it becomes indirect Q2, and then indirect Q2 is exactly this series of numbers that we had for Tesla. So it gives me the monthly variance for Tesla, and that's the way that you can use. So essentially, the function indirect refers to the equivalent to the series that is AAPL underscore R refers to, yes, represents. So, and then for annual variance, I can just say 12 times monthly variance, yes, and then extend. Just, I'm going to do that for all five of them. Great. I calculated all the averages and variances. That's really good. That's really helpful. Now, so when we want to do portfolio optimization, we have to do something. We have to calculate risks and returns. For that, it's very important to know how to calculate all the risks and all the returns. How can we do this? Let's see the formula that we have for all the risk and all the returns. The formula for portfolio return or portfolio expected return is this. ERP equals weights times expected return of each individual assets. Now, we just calculated these expected rates. We don't have expected rates. We are using historical rates as the proxy for expected rates. But essentially, I have this formula, and I'm going to keep this in mind when I want to use uh, the when I want to use this, uh, let's say, returns. Yes. So this is a return of the portfolio or portfolio return. Another thing that I have to calculate is portfolio risk. Yes. So I'm going to just keep this in mind that this is sigma from I1 to N, and then the calculation is WI times ERI. So this is the formula for uh, the portfolio return. How about portfolio risk? Portfolio risk, that's another thing that I have to calculate. So for that, we gotta know the formula for portfolio risk. The portfolio risk is given, it's a little bit mathematical, but this is what we have, yes. Portfolio variance is given like this. Let's call that portfolio variance, and this is the formula that we have. Yes, so I'm going to call this portfolio rather than risk variance. And the formula for this is this guy that we have, yes. So W prime VW, where W is the is all the weights that we have. W prime is the transpose of this. And here, V is variance covariance matrix that we have. So I'm going to just type this. V is the variance. Some books, some authors call this just variance, covariance matrix, or some people just call it variance covariance matrix. So we have to see how to build this. As we know, variance covariance matrix is this matrix that shows how any two assets on the portfolio, how they move with respect to each other, how they co-move, uh, and it's a n by n matrix. So in this specific portfolio that we are trying to optimize, is going to be a 5 by 5 matrix, and it's going to show us how any of these two assets move with respect to each other. So I'm going to come here. The very first thing we have to do is to calculate variance covariance matrix. Yes, I'm going to give the title to this variance covariance. Without this, you cannot calculate the risk of the portfolio. Covariance matrix. This is the title that we have. And then I'm gonna just copy all of these names. Like let's say right here. And then either I'm gonna write them in a vertical format. Since I'm lazy, I'm gonna do paste special transpose. Transpose means if it is horizontal, it makes it vertical and other way around. So I'm going to paste transpose. And what I want to do is to fill up these 25 cells, yes, with proper appropriate numbers. And the formula comes from here, yes, W prime V. That's the portfolio variance. Here, I'm forming this I want to calculate this matrix V. So if I want to calculate this variance covariance matrix, how can I do that? So in Excel, we have this formula called equals covariance. That's the one that helps us. So again, we have covariance.p or and covariance.s. Can you guess which one we are going to be using? Absolutely. We are going to use covariance.s. So right here, I'm going to write use, let's say, equals covariance dot s. So I'm going to type equals covariance dot s. And then I want to say, for example, uh, this guy, comma, this guy. So covariance between Apple series and Apple series, and then Tesla series and Apple series. But if I do this, again, I'm going to get this division by zero error or something. That means that, hey, I don't know what you mean when you say cell W2 or cell V3. So again, what's the solution? Exactly as what we did over here. Yes. Remember what we did over here? We over here. We said indirect P2. We're going to be doing exactly the same thing. Since we by these words we mean that series, I'm going to say indirect W2. Yes. And then one more time for here, I'm going to say indirect W3. And if I hit enter, it gives me all the number that I want. Perfect. That's very good. It looks like that everything is resolved, and all I have to do is to just drag this to the right, and hopefully I get all the answer. Let's see. Oops, I didn't get that. I got the reference problem. So what's the problem? Let's double click on this cell to see. So when I double click, I see that here, this one became X, like this one. I dragged it to right, yes? So this cell, W2, became X2, which was that I wanted that. However, this cell becomes W3. So it's calculating the covariance of X with number 63.61. Now I want to tell Excel that, hey, no, I didn't mean to here W3. I meant uh, just stay at V3. So how can we fix, like here for the blue one, I want to fix the row, and for the red, I want to fix the column. I don't want the column change. The way to resolve this is to calculate it with indirect W. So when you're doing the blue one, the one in row, I want to fix the row. I'm going to put a dollar sign before that number two. When you put a dollar sign, it fixes whatever comes right after that. And here for this column, I want to fix the column names. So I'm going to put a dollar sign right over there. And I'm going to hit enter one more time. And let's see if this time it works. Absolutely. That's beautiful. And if I want to do for all the tables, all I have to do is to drag this down. In this format, we calculated variance covariance matrix. Yes. So this is the way to just calculate that variance covariance matrix. Yes. Perfect. Now that we have this variance covariance matrix, I'm a little bit worried. Did I do everything correctly or not? In order to just check if I have done everything correctly, let's take a look at the diagonal elements of this table, this variance covariance matrix. The diagonal means like this 60.3.61, 325, this one 29, and 20. I know that these must be equal to the variances of individual assets. So I calculated the variances before 63, 325, 47, 29, 20. So if I have done a correct, if I have done this correctly, then the main diagonal for this variance covariance matrix must be exactly equal to the second row on this averages and variances matrix that I have. So let's just check those numbers. Are they equal to each other or not? So the first one is 63. Here we got 63, 325, 325, 47, 47, 29, 29, 20, 20. That means I've done a correct job. Great. So now I got variance covariances matrix and I've done all of these things. Everything looks perfect. So let's see what we are, and what we are heading to. So I downloaded the data for 5 different companies, pasted them as values, calculated all the changes, and then I've calculated all the changes. I have calculated the averages and variances, and then I calculated the also variance covariance matrix. Yes. So far so good. Everything looks good so far. Now that I have done everything, let's see how we can progress. So now I want to calculate the portfolio return and portfolio risk. For that, I need to make a matrix called matrix of weights. And it should be vector matrix. So I'm going to just select all of these numbers and then I'm going to just uh, so I'm going to attribute different, let's say, arbitrary numbers, right, to them. So what can be our first guess? Like if I have five different assets, and so the sum of the weights must add up to one, yes? Now, what should be the sum of all of these weights? It should be one, yes, because that's the ratio. Now, if they want to add up, if I want them to add up to one, what should I do? I have five different numbers, they must add up to one. So each of them should be zero point 0.2 or one-fifth of one. So I'm going to say zero point 0.2, zero point 0.2, zero point 0.2, zero point 0.2, zero point 0.2. This is not an optimized portfolio. These are just initial weights that we want to assign. So, however, I want to make sure that the total weights is, which is sum of all of these weights, is equal to 1, which is perfect. Great. Now I calculate, I started these weights, and if I have the weights and variances and averages, I can easily calculate my next important thing, which is portfolio. Then I can say, let's say, monthly rate, and then I can say, uh, so it can, the portfolio can have monthly and then annual, different things. What am I interested in? First of all, I'm interested in return. What else am I interested? For example, I'm interested very much into the variance. However, risk is defined as standard deviation. So I'm going to say standard deviation, STD, and then in parentheses, risk. Yes. So given this matrix and this, I can easily do that. Now, how can we calculate this? So we can use something called uh, matrix multiplication. The matrix multiplication is shown with matrix multiplication. In Excel, that's given by M mults. Yes, with M mults, that's given to us. So I'm going to just do this M mults right here. So it's equals M mults, and then I want to say all of these returns, monthly returns, times all of these monthly weights. And I click and I get 1.99. That's really good. 1.99. That's if I had these weights and these returns, the average would be this. And then the annual is very easy, 12 times this guy. Good. The variance is a little bit more complicated. Yes, for the variance, this is the formula that we want to use. Yes. Now, so the first thing is W prime. That's transpose of matrix W. So the way I'm going to be using this, I'm going to say equals M mults. And then first thing is transpose of this matrix. So in Excel, I can use the matrix, the function transpose, and then select all of these. Yeah. So that means transpose of that. Comma, then again, matrix multiplication of this guy by W itself. So I'm going to do another M mult, and then I'm going to select all of these numbers, and then I would select same numbers without transpose and hit enter. Perfect, 37. So this is the formula that we used, yes. M mult, then open the parentheses, transpose, select all the weights that you have, not the total. Open the close the parentheses, comma, another M mult, all of these weights, and then comma, this like the weights one more time. That gives you the variance. If I want the annual variance, this is gonna be equals 12 times this guy. Perfect. And standard deviation is just square SQRT, square root of this number. And if I want it for that one, I can just drag this to right. Perfect. So I calculated all of this. This is the for the portfolio. I got the monthly, I got the annual, I got everything. Yes. Perfect, perfect. Now that I got everything, how can I calculate, how can I optimize my portfolio, maximize the risk for any given level of return? Now, I can copy and paste this first of all somewhere because whenever I use Excel Solver, it's gonna overwrite all of these numbers. However, these are not gonna help me that much. So the way that you can paste it as values, either you can paste it and then just right here click on values, or just right click and paste values. Yes. But I keep in mind that this is not an optimized portfolio. It's just equal weight. It's our initial points. Now, we're going to get to the optimization in a second. So, if I want to do a optimization, I go to data, I go to solver. Now, look at this solver. Set objective. What do you want to maximize? What's the goal? The goal is to maximize this annual return. Yes. So when I click on that, sometimes it just gives me calculation underscore. It's just the name of the tab. It's absolutely fine. Or you can just get rid of that and click on, like, just say X19. I don't mind that being there. It doesn't bother me. By changing variable cells. So what is the tool in your hand? It's this one. Changing variables. These five from W11 to W15. Great. And then subject to the constraints. So these are all the constraints that we have. We can put them right here. Number one constraint is, so I'm going to add different constraints here. Number one constraint that these weights must be greater than or equal 0. They cannot be negative. That's one constraint. Number two constraint that I have is that this guy, the total, always must be absolutely equal, not less than, just exactly equal 1. Oops, what happened? Oh, I hit escape rather than 1. Sorry. I'm going to just do it one more time. Add, and then click on this cell, then equal, then constraint 1. Okay, perfect. Then this is maybe very important part of this constraint optimization. I want to put a limit for my risk. I'm not willing to take any level of risk. Yes. So I want to do this portfolio optimization. I'm going to make an argument that the risk annual STD must be less than or equal as a specific number. So I'm going to come here, click on add, cell reference is annual STD, less than or equal constraint. So what should we put here? So we don't know exactly the minimum number for this constraint. So once I'm going to put ridiculously low number that I know it's not going to be less than this, 0.001. And I'm going to ask Excel to solve it. So I put all of these. I notice the third one is not realistic. It's not gonna, Excel cannot adhere to the third condition. So it's gonna give me some kind of error or modification or something. But if I click on solver and then it's gonna give me this, keep solver solution, I'm gonna say yes. It's gonna give me these numbers. Here, the annual risk is not less than 0.001. However, it is the bare minimum that it could, like the risk of this portfolio cannot be less than this. No way it can be less than this. Yes. So since I know this, I'm going to just copy and paste all of these. Why am I doing this? Because every time you do this portfolio optimization, Excel overwrites all of these numbers, and I don't want to lose these numbers. So I'm going to just copy them and paste them on this line, let's say, I don't know, O or P24. And then I'm going to make sure that I paste them as values. So I'm going to come here, paste values. Or you can just right click, right on this cell, let's say P24, and paste them as values. Now I did once for the bare minimum uh, risk. Now, next time, I'm going to come back to the solver. I'm going to change this. How would I change this? Next time, I want to see the maximum possible risk. What's the highest amount of risk that this portfolio takes? So before doing that, maybe we can talk about interpretation of this a little bit. So for the bare minimum, it tells us that, hey, don't buy any Tesla, zero weight on Tesla. 2.1% of your portfolio on Apple, 15% on Google, 33% on Walmart, 49.6% on Coca-Cola. That gives you the bare minimum risk for your portfolio. Yes, that's the way. You cannot go below this risk level for this portfolio of five different stocks. Great. Now I'm going to do the highest. I'm going to change this and put a ridiculously high number for this, 1,000 or 10,000 or something. It doesn't matter. So essentially, here I'm telling Excel that I don't mind the risk. Whatever the risk is, I'm fine. So, and I'm gonna just say solve. As soon as I do this, and click on OK, Excel gives me this. First of all, that's 1.000000002. That's like rounding error. It's just essentially just one. Yes, the number is just one. Don't mind the rest of it. But essentially says that the riskiest is that you just buy Tesla. It's very, very risky. The highest amount of risk possible is 62.47. So I'm going to just select all of this. And so I did P24 here. I'm going to go all the way to the right. Somewhere maybe here, P, and then, yeah, it's good, maybe over there. I'm going to paste it on maybe a little bit, maybe more here. And I'm going to make sure that it's pasted as values. So that's the maximum risk. So the minimum risk Later on, we have to make a table called risk return. Yes. So here is risk, here is return. And I'm going to just select all of these risk, different amounts for risk, and then appropriate amount of return for each of this. So later on, I'm going to be using this. However, I keep in mind that the minimum risk was 13 and then the maximum was how much? 62.4. So I'm going to do like, let's say rather than 13, I'm going to do maybe one more time. Different levels of risk that I want to do. Maybe 17 and then three more uh, or like 16.5, another one 20, uh, 25, 30, 35, 40, 45, yeah, 35, 40, 45, 50, 55, 60, and then the last number that we had for risk, 62. I already know the return for this one, 52.1. And by the way, that 52.1 is going to be exactly the uh, return for Tesla, annual average return for Tesla. So what's happening here? Here, I say that I know the risk is going to be between 13.37 and 62.4. So I'm going to do, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points in between. And then the minimum and the maximum of the risk are these two. Each time I want to calculate the return. How do we calculate the return for each of these? I'm going to each time go to solver, then change this to what? To those numbers that I had 16.5, 20, 25. And each time I'm going to copy and paste the result. So I'm going to say this and then solve. Okay. And each time I have in my mind that, hey, take a look at the annual risk, 16.5. That means we have done everything correctly. Copy and paste everything. Copy and paste. Maybe, I don't know, here. I can just put one column maybe in between so I don't get confused later on between two different things. Paste values. Then I'll go back there. Maybe it was a better idea. Okay. So that was one thing. Then rather than 16.5, let's do change this one. So you don't have to change any of the other things. Just change this one, 16.5 to 20. So if you do it twice, then from that, it's gonna be really quick. Just 20, okay. I got this numbers, copy and paste everything. Here, paste values. I'm gonna keep going. 25, change 25. Okay, so just once you do it once, it's gonna be super easy, super fast. Copy this, paste it over here, paste values, then 35. So I did 25, then 30. Copy that. Change to 35. So As I'm increasing the risk, less risky assets like Walmart and Coca-Cola, they're getting less and less weights. So here at the beginning, they had like Walmart has a very good, or like Coca-Cola and Walmart has like very high weights. But as I'm willing to take more and more risk, like Coca-Cola became zero, and then Walmart is becoming less and less weighted in my portfolio. And so you can see the transition of all the uh, weights as I am changing the risk amount, and I'm willing to accept more risk. Now, Tesla is becoming more and more important in the amount of risk that I'm willing to take. I need more space. I'm gonna just copy this and paste it a little bit toward the right. So maybe on here, because I need more space. I'm gonna do 45, 50. So uh, yeah, Google is 30%, but paste values. So that was 40. What if the risk level is 50%? Is 50%, then it's gonna be this much. Now, Apple is also zero. More weight for Tesla. And that makes sense because Tesla is the riskiest asset with highest return. So 50, two more, maybe 55 and 60, yes. So 55, 55, and one last thing. So I'm gonna just move this one more time to right, maybe here. And then one last one, I want to do portfolio solver, and I'm gonna change this 55 to 60. Click on OK, solve, OK. And that 60 is like mainly Tesla, but 4.5% of portfolio is Google as well. Awesome. We did the portfolio optimization many times. I got all the risk levels and I got the appropriate return for them. So all I have to do is to go and copy and paste these numbers. I can just easily do this, paste all the numbers. There's a way that you can do all of them at once as well. Just on Mac, hold the command button down and select them. I'm gonna just do one by one. 30, 36, 40, 45, risk level of 45, risk level of 50, risk level of 55 and 60. Yes, so 55 is right here, and then last one 60, and that's the return for that. Perfect. Now I got this risk and return. I can just select all of this, easily go to insert, go to put this curve, name it uh, efficient frontier. Here, uh, and here I can give a name. Let's say to if I go to add chart elements, axis title, primary horizontal, I can just say this is risk level, standard deviation, and then I can go one more time here, primary vertical, and then say return. Perfect. So I made this efficient frontier, which means for all of these points, for each level of risk, for the given portfolio of five different stocks, these are the maximum amount of return that we could get. So if we had, for example, a portfolio like this, let's say not optimized portfolio like this one, risk is 21, return is 23. So if risk is 21, return would be 23. So it's going to be below this. So that specific point would be somewhere right here. Any unoptimized portfolio, yes, any portfolio which is not optimized would lie below this curve. We always want to go up. For any level of risk, we want to have a higher return. That's definition of rationality. A rational person at any given level of risk wants a higher return. And if they don't want that, introduce them to me. I can talk to them. I can convince them that, okay, you take the whatever return you want, give me the rest of it. Yes, I would happily accept the rest of the money. Uh, However, the points above this efficient frontier, they are unattainable. The points below that, they are not efficient. They are not optimized portfolios. Only these points are optimized portfolio. But out of all of this, what should be the appropriate level that we are interested? So let's calculate something else that we call Sharpe ratio. Yes. For Sharpe ratio, we had the formula. Yes. Sharpe ratio is defined as excess return of the portfolio over risk-free rate minus the risk of the portfolio. So I'm going to take that definition, uh, and I'm going to write it right here. First of all, Sharpe ratio. So Sharpe ratio is defined as this guy. Oops. So portfolio. I guess I can't copy and paste. I'm going to just write it. Portfolio return minus risk-free rates divided by portfolio risk. Now, if that's the definition of a Sharpe ratio, let's calculate that and let's just try to maximize that portfolio Sharpe ratio. So in order to calculate Sharpe ratio, I'm going to go back to calculation and into this matrix. So I'm going to assume that, for example, risk-free rate is 3%. The annual risk-free rate is 3%. Then I'm going to calculate this Sharpe ratio thing. Sharpe ratio, and it would be equal the annual return minus this 3% divided by portfolio risk. So here that zero point 0.7, so this is the formula one more time. Yes. This 0.796 is not the maximum Sharpe ratio. It's just Sharpe ratio for this specific uh, portfolio that we have. I want to maximize this. How can I maximize this? As you can easily guess, go back to solver. Whenever you want to maximize, go back to solver. Now, set objective is not going to be returned anymore. So rather than x uh, 19 is going to be x 23. So I'm going to change that to x 23. And then, since already the standard deviation risk is included in the formula in the denominator, I'm going to just delete this point. And I'm going to say solve. The maximum Sharpe ratio is this 1.067. And that happens when you buy zero of Coca-Cola, 17% Apple, 12% Tesla, 39.5% Google, 31.1 or 0.2% Walmart. So I'm going to copy this and I'm going to just have this maybe over here. I'm going to paste it and paste values. I'm going to say max Sharpe ratio. Sorry, max Sharpe ratio. Great. Now that we have this maximum Sharpe ratio and everything looks good, let's also add one more thing. Yes, we want to add another line called capital allocation line. So I'm going to write that capital allocation line. Capital capital allocation line, and then cal, and for that we have to know the line itself. So a few points on the line, it would be, let's say, risk-free rate 0. So we have again two columns, yes, risk and return. Risk and then return. I'm going to make them vertical maybe here. Risk, if risk is 0, return would be 3, risk-free rate. Also, Sharpe ratio is on this point as well. The Sharpe ratio would be on this. So for Sharpe ratio, I know that if standard deviation is this much, return is this much. And I can easily calculate, like, let's say, other points on that line as well if I'm interested, which I am. So the equation for this line is something like this. Equals, so return would be equal to risk-free rate RF plus the slope of asset allocation, capital allocation line is Sharpe ratio. So that's the uh, slope. So I would say slope times amount of risk that I am willing to bear. Oops. So that's the formula for this. So if risk is 19, then this. What if risk is 40? If risk is 40, then this guy would be a risk-free rate, which is 3, plus Sharpe ratio, the maximum Sharpe ratio. Yes. So here I'm gonna say uh, this guy times risk, which is 40. So it would be this much. So it's maximum Sharpe ratio. So I got these points and I want to make a line. So all of these 3 points are on the same line. I want to overlay or superimpose that line to this graph and see what points we are interested in. And so if I have this, let me see how can I make this. So if I click on any points on the graph, and after that, maybe we can go to chart design, and then chart design, select data. So click on the graph, chart design, select data. And I would add another series. I would call this series capital allocation line. How did I add? I just clicked on this plus sign. And then, no, not that, that's the range. The name would be this capital allocation line. And then I would select my X values and Y values. So X values are uh, these values, and then Y values would be these values. And if I click OK, yes, exactly. I'm gonna get this points, this line, yes. So you see that orange dot over there, that's this point that we have the maximum Sharpe ratio. It's a little bit, you see the risk is 19.6. It's a little bit before the uh, blue dot over there. So it's like 19.6. And this is the capital allocation line. And that's the best combination of risk and return. So if you want to choose one point, it can be this one. The points on the right of this, you can select them. You can just, if you combine, like let's say risky assets, like these, and risk-free assets. And the lines, the points on the right of this is on capital allocation line. They are possible if you use leverage. If you borrow money at risk-free rates, 3% in this example, and you use a leverage, then you can do that as well. Go to the right of this. So yeah, that's everything. Just to make sure that we know how to overlay this line, I'm gonna write here how to overlay or superimpose capital allocation line. So these are the things. Click any points, any points on the graph. Click on chart design, then chart design, and then select data, design, then select data. Click on the plus sign, to create another series and choose X and Y's. Yes, so that's the way to do it. So perfect. We made our efficient frontier, the capital allocation line, the superimpose the tangency point, which is the Sharpe ratio, and that's uh, completes our analysis, portfolio optimization using Excel Solver. Thank you very much, everybody. I hope that you enjoyed this course. I hope you. Uh, this course has is not an investment advice. It's just to know how to do portfolio optimization. But I hope you really enjoyed and you uh, do this on your own computer and get the hands-on experience. Thank you very much. Have a great time.